Okay, I think this is probably as good a time as any. I want to thank everybody for coming to this event. This is a great milestone for us to see VisualCAMc, and it's being released to the market with its full functionality for the first cloud-based CAM app that has really been produced. And we're joined by Uday and Joe and myself. I'm Joe too, so we have two Joes. And Uday, why don't you go to the next slide? I can't remember if we have introductions to ourselves and everything. We are going to record this, everybody, so you don't have to worry about that if you have colleagues or somebody that wants to see it or watch it again, because I'm sure it's going to be so exciting you want to watch it 2 or 3 times. We will have it recorded. That's always the way to go. But I think most importantly for these webinars, the best thing you can do is ask questions, because you can always watch a video anytime and see a product. But this is where you can talk to Uday, talk to Joe, talk to me, and really find out more details about specifics, and that's something that's not possible typically. Next slide, please. So the idea is going to be a quick introduction that you're hearing from me. And then mainly, I'm not even going to, I decided let's just not do too much of Onshape. I think that the whole point of this is once you build a part in Onshape, how can you get it built? This is a subtractive manufacturing topic, and how can you create the toolpaths? How can you send it? What can it run on? How does it work? All this. So this is it's really exciting to be able to see, cutting real materials out of, metals and different stuff instead of just squirting, instead of the 3D printing stuff. So I'm a big fan of CNC, frankly, because it's a real man's tool. So Uday will do a demo, and then, like I said, what we really should be doing is do a lot of Q&A at the end, and we can answer more questions. And Joe and Uday, why don't you guys introduce yourselves?
Uday, you want to go to the next slide, please? Yeah, this is Joe, and you can call me Joe A, because we have Joe D, the other Joe, online as well. So anyway, I'm the president of MecSoft Corporation. For those of you who don't know MecSoft Corporation, we've been in business for 20 years. I have a MS in mechanical engineering from Clemson University. It was a long time ago, 30 years ago to be exact. And I have all my 30 years of my career has been in the CAD/CAM industry. Started out with GE Calma. Some of you old folks out there who might know GE Calma was absorbed by computer vision, and then later on by I don't know who. Anyway, Intergraph, and then Unigraphics, which is now Siemens PLM, and then I started MecSoft about 20 years ago, and we've been focused on producing CAM solutions for the CNC market. So you can reach me at joe@mecsoft.com if you have any questions, and that's me. So Uday, you want to introduce yourself?
Thank you. Hello, everyone. Good morning, or good afternoon, or good evening to you all. My name is Uday, and I'm with MecSoft Corporation since 2005. I have a master's degree from Arizona State University in industrial engineering. I started out as an application engineer, and now I handle the roles of a technical support manager at MecSoft Corporation. And I'm really excited with the cloud-based solution we are offering in Onshape, which is basically our pioneer desktop product, which is now being offered fully on the cloud. And you can reach me via email at uday@mecsoft.com. Thank you.
Just in case anyone, I don't know what you got, you can go to the next slide, but I don't know if I'm even on here. Yeah, just in case, last thing is, I'm Joe Dunn. Most likely, oh, there we go. Most likely you guys have seen me in one of these webinars before, but, I was with SolidWorks for a long time, and now pretty much everything related to the Onshape App Store and partner-related activities are things that I spend my time on. All right, Uday, it's all yours, sorry.
Okay, so before Uday jumps into the demo, I want to talk a little bit about MecSoft. A few of you attendees might not know about MecSoft. We are actually a developer of computer-aided manufacturing software products running in the cloud now, as well as desktop, Windows desktop for manufacturing parts in a wide variety of industries. We've been in business for 20 years, like I said, and most of our products are on the Windows desktop, but this is our first foray with our partnership with Onshape to release the VisualCAMc product. We call ourselves, our tagline is we are your CAM partner. What that means is we just don't sell you a product. We support our product. We stand by our product. So if you have CAM is a very, manual and very manual intensive industry where you need a lot of hand holding in terms of interfacing with the machine tool, making sure the post-processor works correctly, things of that nature. You might have a part that a special part or complex part that comes around that you don't know how to machine. So we are there to back you up. We are your partner. We got to make sure you're successful with our CAM products. So that's really our tagline, and we stand by it. So next slide, please, Uday. Yeah, we are a California-based corporation. We established in we incorporated in 1997. We actually started work on the products in 1998. So this is actually our 20th year. We have customers in over 50 countries, been expanding, started basically in the U.S., and now we have customers in almost all the major manufacturing countries in the world. We have desktop products that have been translated in 6 major languages, including Japanese, Chinese, most of the European languages, and of course Spanish as well. So, all right, Uday. Like I said before, we target our CAM products to a wide variety of industries. There's a lot of different applications where our CAM products are used. Production machining is probably our biggest application, and also where VisualCAMc plays very well with the current set of functionality. Woodworking, furniture making, that's also an important market for us. Mold and die machining, aerospace and automotive. Big market for us as well. Musical instrument makers, guitars, ukuleles, violins, quite a few of that nature. Jewelry and artistic machining, that used to be one of our mainstay, but most of the jewelry makers are now going to 3D printing, so we see that less and less these days. Prototyping, that's important. Prototyping, even though it is going to rapid prototyping a lot, but a lot of different materials where people cannot use rapid prototyping, CNC still plays a major role, and that's an important market for us. And education is also a very large market. One of the things in our product is really easy to use. Students find it very easy to get their hands around or wrap their brains around it. And also it's very easy to teach and learn. So that's one of our strengths, and that's why we are very strong in education. So a little bit about our desktop products. Actually, our products, because VisualCAMc is included here as well. We have VisualCAD CAM, which is one of our mainline products. This is a standalone CAD CAM product. This is tailored or targeted at machine shop users, people who don't really need that design. The VisualCAD front end is really for importing design models and then machining it on a shop floor or in a single user situation. Rhino CAM is also a very strong product for us. It's a plugin that runs inside the Rhino NURBS modeler. And then VisualCAM for SolidWorks and Libre CAM. These are 2 plugins that run inside parametric modeling systems. SolidWorks obviously everybody knows, and then also Libre Design, which is a relatively new product. And then finally, our latest offering is VisualCAMc. This is completely cloud-based app working in conjunction with the Onshape product. So we have built-in associativity with the Onshape design, and that's the thing that you're here to see today. So next slide today. Yeah, this is our latest and greatest, VisualCAMc. It leverages all the 20 years of our CAM experience in the desktop, and we have learned a lot in the 20 years about what not to do and what to do in the CAM products, and all of that intelligence is now, you get the benefit of all that intelligence and knowledge in the VisualCAMc product, not only in the user interface, the way you work with it, the workflow, and all of that. So right now, the first version of this, which was released in October 2, which is Monday of this week, allows you to do 2.5 axis, 3 axis, and also 3+2 axis milling. Some people might know 3+2 axis as 5 axis index milling. So we have these kinds of operations or machining strategies available in the product. Some of the bullet point items about this product is fully cloud hosted, which means you don't have to do any downloads. You just load up your browser and it's ready to go. updates are automatic, so you don't have to worry about service packs and things of that nature, keeping in sync with some of your colleagues who might be working with the same product. And like I said before, it uses MecSoft's proven desktop CAM technologies, fine-tuned over the years, used in production in over 50 countries now.
Don't forget, runs on every platform, right? So
yeah, now it runs on every platform. Every platform that supports a browser, it runs. So it's an important feature now. So, and then the commercial release, like I mentioned, was on October 1st, which is Monday of this week. We're very excited to be showing this product, and it starts out right now. The monthly subscription is $99, and it's a great time to get into this product. So we're very excited, and I'm sure you'll see why when Joe and Uday do the demo here in a minute. Thanks, guys.
Thank you both. So folks, we will be giving you a demonstration of VisualCAMc in Onshape in just a moment. And if you have any questions during our demonstration, you're welcome to post those questions in your questions panel, and we'll try to get those questions answered to you as quickly as we can. So without any further delay, I'm going to go ahead and jump into a demonstration here. So what you're looking at is an assembly of multiple different parts that has been modeled and built in Onshape. You can see that we are looking at the assembly on this tab here. So I'm going to switch over to the tab that says housing in here, and this is one of the components we will be looking to machine here, or generate toolpaths for machining for this particular component. So I'll walk you through the steps on how we go about taking this CAD data, the part that you model, and how we can turn this into a machining data, which you can then send it out to your CNC machine with the help of VisualCAMc. The first step is you would need to subscribe to VisualCAMc app by going into App Store from Onshape, and I'll show you how to do that towards the end of the demonstration. So once you have subscribed to the app, you just go over from your document, you insert a new element, you select Add Application, and then choose VisualCAMc. So VisualCAMc will automatically load in as a new tab within the same Onshape document that you're working in, and it will give you the ability and controls to load a part or a part studio from your current document that you're working with. So in this particular example, I'm going to pick the housing as the part I would like to program and generate toolpaths and post-process this out to a CNC machine tool. So as you can see, the model is loaded. And by the way, as you notice, everything is happening on the cloud. Nothing is being driven locally here. It's just from a web browser. And once the model is loaded in here, the first step you want to make sure is you can see all of the interface of the CAM being loaded. You have your machining browser interface, which appears over here on the left pane. Very similar to what folks, if you've used our desktop product, you're seeing a machining job, and you'll see all of the entries in here. You also have a tools tab where you can define different types of cutting tools. You can also bring in a library of tools. So the workflow typically is working your way from left to right as you work through these toolbars across the top. The first step is to establish your coordinate system for machining. So as you load the model, VisualCAMc automatically inherits the orientation of the coordinate system, the way which the model was built. So you can see that the blue arrow represents your z-axis, the red arrow represents the x, and the green represents the y coordinate axis. Now in order to be able to program this part, I would need to orient my coordinate system so that the z-axis is normal to this face where the holes are located. So I'm going to use the controls in the machine coordinate system tab in here. I'll be rotating it, and as you can see, it's updating the coordinate system orientation, and I'm going to save this in here. Now once the coordinate system has been established, in the next step we would like to select our post processor. VisualCAMc includes post for over 300 plus different machines and controls, which covers a wide range of machines that are out there. You can also custom edit posts and build new posts and add them to it here. You can also have your favorite 5 post list of machines can be set right in here. And for this demonstration, I'm going to use FANUC as my controller. If you'd like to use one of your custom built force, you can use load from files option to import the post processor into VisualCAMc. I'm now going to select close, and you'll notice that the post processor information is updated in the machining job. In the next step, we would like to build our stock material. So we're going to select stock, and you can define a stock either as a box or a cylinder. For the part that we are programming today, we would be using a box stock in here. And as you look at the stock, extents is automatically determined based on the part that's being programmed. I'm going to add a Z offset to the stock, and this is automatically being displayed in real time on your graphics screen as you notice it. I'm going to hit save. In the next step, you would like to establish your work 0 or program 0. This is the origin that you would establish when you do a tool touch off or your work coordinate offset for machining the part. So we call it work 0, and I'm going to set this to the stock material. We'll pick the highest Z for the face, and then the corner, I'm going to pick the southwest corner. So you'll notice that the coordinate system origin is now set to the top face and the southwest corner. And if you'd like to output your work offset as a G54 or a 55, you can specify this in here and then save. So each of these steps that you did is automatically recorded and saved in the browser window here, and you can always go back and make changes or edits to it. Now we'll take a look at the different operation types. VisualCAMc offers a wide range of methods in 2.5-axis programming, starting with facing, pocketing, profiling, V-carve roughing and finishing, engraving, slot machining, chamfering, fillet machining, hole pocketing, hole profiling, thread milling, and T-slot machining. Now in Threeaxis, we have different types of 3D machining methods, starting with roughing. We call it Zlevel roughing, also known as horizontal roughing in our desktop products, Zlevel finishing, parallel finishing, radial machining, and spiral machining. And we do offer hole machining, where you can do drill, deep drill, countersunk, brake chip, drill cycles, tap, bore, and reverse bore operations as well. Now to program this part, the first thing I'm going to do is a facing operation to face the material out in here. So we'll go into 2-axis and we'll pick facing. Now this automatically displays the controls for facing, where you can start by selecting a tool. As you can see, it's a tab-driven interface. It's very easy to use. You can define your tools by going to the Tools tab, where you can create tools of different types. We support ball and mills, flat and mills, corner radius tools. V-mills could be used for engraving, chamfer machining, thread mills, taper tools, face mill cutters, dovetails, fillet mill tools, lollipop cutters, and of course you have the drill, center drill, reamer, tab bore, and reverse bore. So you have a wide range of tool types that you can create, and you can either create your tools by defining your tool properties in here. We can specify the tool diameter, the flute length, the shoulder length. You can input all of these parameters in here by just typing them in, or you can even save the tools into a library and load them from your library. You can also assign your tool properties, like your tool number, your height offset register, your coolant type. Each of these can be set for each tool, and as you save this information, it stays in the session. I also have a library of tools created. I can import my libraries by just importing a CSV file, and I can select the tools that are in my library and drag and drop it into the tools and document. So that's how easy it is to load a library of tools and add it to your document. Now let's switch back to our machining job, and you'll notice that for the facing operation, it automatically restricts the tool types based on the operation type. So for this particular operation, I'm going to use the face mill tool, and as you select the tool, you'll see that the tooltip automatically displays your tool number, your holder information, tool diameter, length. All of the information is available at your fingertips. The next step is to jump into the Feeds and Speeds tab, where you can specify your spindle RPM, spindle direction, your feed rates for plunge, approach, engage, cut, retract, and departure. Coolant type can be set right here as well. And then you go down to a clearance tab, where you can establish your clearance definition. And when you select this tab, you'll automatically see the clearance plane is made visible in the graphics window. You can adjust these using any of these controls. And then finally, we go down to parameters, where you have 4 sub-tabs where you can specify your tolerances, your cutting conditions in here, your cut patterns, your step overs. Each of these parameters can be set. You have the finest amount of control and granularity that's available in here. You can control your step overs, your entry and exit. You can specify each of these parameters in here. So you have all of the details and the controls that you're looking for, which is available equivalent in our desktop product. So I'm going to pick generate, and the toolpath is being computed, generated, and it's delivered back in here. So you see the facing toolpath appearing in the graphics window. We can also toggle the display of the toolpath by using the controls over here on the side. Now once the toolpaths have been generated, you would like to go ahead and run a simulation. So selecting the operation, right-click, and simulate performs a cut material simulation. You can control the simulation speed. You can also have controls for pausing and simulating to end. So once the simulation has been completed, we'll exit the simulation and we'll program a few other operations. So we see a few cavities on the model in here and also some core regions. So to program these cavities, since they're sculpted areas and there's fillets on the model, so I'm going to start with a 3-axis roughing operation. So we'll pick 3-axis and Zlevel roughing. And in this dialog, I'm going to pick a tool, so we'll switch over to a 1/2 inch flathead mill. Again, the workflow for defining feeds and speeds and clearance is very similar to what you noticed in the previous operation. We'll go into parameters where you can specify your cutting conditions. You can choose to automatically have VisualCAMc determine facing cut patterns for core regions and cavity cut patterns for cavity areas in the model. And each of these can be set right in here. So we have different cut patterns for cavity regions, starting with offset, offset spiral, linear, and even high-speed cut patterns available in here. You can control your step-over parameters for each of these cut patterns. You can control your cut levels, where you can specify how fine you want it to step down. You can specify additional containment parameters in here, and each of these can be set. And of course, you can control your entry and exit and any advanced cut parameters, and then select generate to generate the toolpath. Now the toolpath is being computed and delivered back, and you can see how quickly and efficiently you're able to generate the toolpath. So there's scalability available since you're running in the cloud. You can, depending on the intensity and computation involved, it can automatically scale up and scale down of the use of the servers. So the toolpath has been generated in here, so we'll go ahead and run a verification. So we select the operation, right-click and simulate. We'll run a cut material simulation. You can toggle the display of the toolpath visibility on or off. You can also change the simulation speed in here as you're simulating. And of course, you can rotate the view during simulation. And this is all happening in real time. We can do a pause, and then hit simulate to end to run through the simulation. So stock has been roughed out. So the next step is we can go ahead and program a few additional operations in here. So I would like to finish off the front areas in here. So I'm going to use a profile operation. Select 2-axis and profiling. And again, I'll use the same 1/2 inch end mill for it. Set the feeds and speeds and clearance. Then go down to parameters. Now for the profiling operation, I would like to restrict the toolpath to a specific area. So I'm just going to right-click on this, and it'll automatically select a chain of edges that are planar to the face. I can specify my cutting directions, cut start side. For the depth, I can actually pick it from the model. Graphical selection by just making 2-point pick. And the total depth is determined. We'll break it up into multiple steps, specify entry and exit, and then generate. So the toolpath is generated, and you can display the toolpath by toggling the visibility on. Right-click and simulate runs the cut material simulation. Now to program these holes, I'll go into a drilling operation, so hole machining and drill. And depending on the operation type, you'll notice that the tool types available for drilling are drill, center drill, or a reamer. So I'm going to pick a 1/2 inch drill bit. Again, specify my feeds and speeds and clearance, and I'll jump into the cut parameters where I can just select the holes in here for drilling and specify the depth and additional parameters and then generate it. So the drilling operation has been generated. I'm going to hit simulate to run simulation. Now finally, to finish the features on the cavity in here, I'm going to use a 3-axis operation, and we'll start with axis parallel finishing. And for finishing operations, typically you would want to use like a radius tool, like a ball and mill or a corner radius tool. So I'll pick a ball mill quarter range, set feet and speeds and clearance, and then we'll go into the cutting parameters. I would now like to contain this finishing operation just to an area, so I'm going to just select a bunch of edges in here for containment. Specify your cutting parameters like your angle of cuts, step over distances, and finally generate the toolpath. So the parallel finishing toolpath is now generated. Now to finish these fillets along the sidewalls, I'm going to use another 3-axis finishing operation in here, and this would be a Z-level finishing operation. So you could program a combination of 2 and 3-axis operations. I'm selecting the same ball and mill we used for the parallel finishing, and for now, for this, I'm going to pick this region in here to contain the toolpaths. The regions have been selected. I could specify the cutting conditions in here. I'll use a step over of 15% and generate it. I'm going to skip the programming of these holes because the process will be very similar to what we did in the drilling operations. I'll run a simulation of the parallel finishing operation in here. Right click and simulate. You could always adjust your simulation speed to have it go faster or slower, or if you want to pause the simulation and skip it to the end, you can select pause and then go to end. So you have all of these controls in simulation, and exiting the simulation will save the cut model and display it on top of the part while in the programming window. Now once you have all these toolpaths and operations programmed, the final step is we need to communicate this to your machine tool. So we do that by a process called post-processing. And like we've already selected a post-processor at the start of your programming workflow in here, we can post it out to the machine tool. So you can either select the entire setup to post-process all of the operations in the sequence in which you program, or you can post individual operations as well. So I'm going to highlight the setup, right-click on it, and then select post-process. So the toolpaths that you programmed are being post-processed, and the generated file is downloaded to your local computer. And you can now view this in a text editor of your choice, and the program is now ready to be sent over to your machine tool in here. Now, I also want to point out that the VisualCAMc product offers the ability to do 3+2 programming, in which you can program the part from multiple sides or multiple different orientations. So in the first setup, we program the part looking down from the top here. If you have features that requires machining from additional sides, like you may have features that needs to be machined from the bottom side or from additional sides in here, you can create additional setups by adding a new setup. So this is called 3+2, where you're locking the orientation for machining to different planes or different orientations in here. In this case, I'm going to rotate it by 180 degrees about the x-axis in here. And you'll now notice that the z-axis is now pointing normal to the bottom face of the part. I'm going to go back and insert a new work 0 in here. I'll pick a higher Z in the southwest corner, and now I can add operations to program features in here. So I could start out with a roughing process for the bottom face as well. To program these pockets, I can select the tool, establish feeds and speeds, and I can pick areas to restrict or contain toolpath by just selecting boundaries and generate the toolpath in here. So you could program your machining operations from multiple by creating setups, and you can simulate them from each of these orientations as well. So the 3+2 ability allows you to program from multiple different orientations. If you'd like to program these features from different orientations, you can still do that by creating multiple setups and programming them.
Uday, so this means that the machine itself will automatically flip the part over, depending, obviously it depends on the machine, but when it goes from setup 1 to setup 2, is this something that the machine just goes automatically to the next step?
That's a great question, Joe. So if you define the machine tool as a 4-axis, and if you're using a 4-axis machine where the part can be rotated on a rotary table, yes, it will output the the rotation angles to rotate the table or the rotary axis by 180 degrees in this particular case. If you define the machine tool as a 5-axis machine tool, then it will each of the setups will output the orientation to get to that. If you only have a 3-axis machine tool, the user would have to refixture the part to manually orient it, and then you can basically post-process each setup out as a separate file.
Uday, can you show the simulation in the second setup, please?
Absolutely. So I'm first going to go ahead and simulate the Z-level finishing, which I haven't completed yet. So once I'm through with the Z-level finishing, I will be able to go ahead and simulate the finishing of the setup 2 as well. So I'll just do a pause and then simulate to end. So that completes the simulation of all the operations in the first setup. And now we'll go ahead and run a simulation of the setup 2 as well.
Once you start building these simulation models, obviously the polygon count on all of these models are going to start increasing, and you're going to see a little bit of a performance hit. That's exactly what you're seeing right now, because we are actually saving the cut model on the server and moving this back and forth from your desktop or to your local device to the server.
So once we have the simulation, the cut model generated for the first setup, we would then switch over to the next setup in here to be able to simulate the next setup in here as well. So which I'll be able to demonstrate in just a moment. Now, while we are waiting on that, I do want to quickly show you, some of the type of toolpaths that you can generate on different class of parts or complexity of models in here. So for example, here you're looking at a high-speed cut pattern toolpath that can be employed in a roughing operation in here, where you can generate toolpaths for very efficient toolpaths for roughing, where it's generated by use of a constant tangential arc, so which you can run it at a higher feed rates, and it basically prolongs your tool life and reduces wear. So here is the simulation for the high-speed cut pattern. While you're looking at the simulation, here you can see that it creates constant tangential arcs in the simulation, as well as the cutting motion. So this is available in both roughing and pocketing operations, the high-speed cut patterns. So you can see with VisualCAMc, you can program a wide range of parts, wide class of parts, ranging from simple to complex geometries.
And just in case everyone didn't really catch what Uday did, this is the whole point of the cloud again, is that, this is all happening simultaneously. So machining is very computative intensive task. Sometimes toolpaths can take, every system will take a long time to calculate, but he can run it multiple sessions here in different tabs. He can go to Onshape and continue to work. You're not stuck with having everything run on whatever computer you're using, and you just have to sit there and wait for it to finish. So.
Okay, thank you, Joe. Folks, as promised here, I have the cut model ready for the setup number 2. So I've switched back to the previous screen. I'm going to select the setup 2, the operation Z-level roughing, and I'm going to just rotate the model view in the graphics screen before I run a simulation. So I'm going to select simulate. So you can see now the simulation will show the cut material verification for the setup 2 as well. So once you've simulated the first setup, you can select the operations under the second setup and start your simulation. Again, folks, if you do have any questions during this demonstration, please feel free to post those questions in your questions panel, and we'll do our best to get them answered for you. So you can see that the bottom side is now being simulated, and you still have the result of the simulation from the top half.
The product is fully associative, and so right now I just created a version. So everything that Uday did on that part on the worm gear, it's just a little hard in GoToMeeting for us to. I would just So it's in GoToMeeting switching back and forth. I'm just going to skip it, but you can see that I'm up there in the tab showing that I'm a user in this design as well, and I can make changes to the part. I actually saved a version. We're in a different branch. So, you know, everything about VisualCAM is honoring all the power of Onshape. So we're, you know, each branch can have its own machining. Each version is saved at that stage. So it's a nice, simple, and proper solution. So in this case, long story short, you know, we have potentially, we want to add a little clearance. We have a clearance problem in the assembly. So I'm going to make a couple changes to this very quickly, and you'll see them visually show up. Let's do this. Make this 0.2. Okay, so I just wanted to do something that is very visual, and you can see that the part now has a much stranger angle. And let's just say, for the sake of argument, this was a clearance problem we had when this part goes together. So very common iterations, right? So I'm the design engineer. I made a change to the part. Now the question is, what happens to all those toolpaths that we created before?
Okay, so folks, since there were some design changes made into the model, I'm going to switch over to the VisualCAMc tab, and you'll notice that it automatically identifies the change in the geometry, and also the user is notified about this change in here. So once you have the changes notified, you just have to go back and regenerate your machining operations, and the toolpaths are automatically being updated on it. So you just have to right-click and regenerate on your setup to regenerate each of the operations in here. And they're automatically updated. So that's how simple it is. So if you make a change, you go back and regenerate your operations. So this basically gives you a quick overview of VisualCAMc for Onshape. And I would like to hand this back to Joe.
Well, there are a few questions, so you want me to field some of these questions?
Yeah, Joe, go ahead.
Well, there's one, first of all, about 4 and 5 axis. So right now we showed 3 and 3 plus 2. So is 4 axis for turning and 5 axis available or coming?
Yeah, actually, there's multiple questions on the questions panel that relates to similar things. You know, one of the things we have a lot of functionality in our desktop product. Advanced 3-axis machining, 4-axis wrap machining, 4-axis continuous machining, 5-axis continuous machining as well. And then other additional things like template files or knowledge bases, toolpath editing, a whole host of other things that we have built over the years on the desktop. And a lot of these features will find their way to VisualCAMc. We are going to be driven by our users, what they want and how they want to shape this product. And so a lot of these features, like I said, will make their way eventually into VisualCAMc depending on user requests. So yes, a lot of these are coming. So the short answer is that.
Yep. And of course, I was in the chat window, so I didn't even see all the questions until just the end. So I apologize, but Joe did a pretty good job of answering them. Pricing, I see pricing came up a bunch of times. So you want to talk about pricing, Joe?
Yes, yeah. Right now, the pricing we're offering is $99, a monthly subscription fee for this product, what you see. And we will be rolling out an annual plan pretty soon. We're waiting on the API implementation from Onshape. We should have that in a few weeks if everything goes well. So, and that will be a little bit cheaper than the $99 multiplied by 12, obviously. So, and as different features come into the product, you know, we might also roll out different levels of the product, like we have in our desktop. We have a Pro version, and we also have a premium version, and we're thinking on similar lines as well over here. So.
There's a question about starting and stopping subscription. So yeah, if you're a monthly subscription in any application in the App Store, you can sign up. If you sign up for the monthly subscription, use it up and cancel it. That's just a standard part of all the Onshape applications in the App Store. So that would be Zachary, or actually who asked that? Owen asked that. So yes. Let's see.
There was one unanswered question here, Joe. It says, when do you select Z-level finishing? Maybe Uday can talk about that.
Absolutely. So the Z-level finishing is ideally used for steep sections, steep areas on a model. So consider, for example, you have a pocket which has a draft on it or like a truncated cone. So it basically does finishing in levels as it steps down following the sidewall support. So if you have areas that are sculpted and not very steep, then parallel finishing might be a good option. So in this particular example, you can see these steep walls. This would have a draft on it. You could have some fillets on it. So you could use a Z-level finishing toolpath. So you're basically able to set the step down between each level in the Z-level finishing toolpath. I hope that answered your question.
Uday, can you also talk about the help and where to get more, go for support and videos and things of that nature so people can get an idea of resources available?
Sure, absolutely. So folks, you can access the help content directly from the VisualCAMc interface. So you just select the help and you have the help topics, which basically gives you access to an online help system, which basically allows you to access, all of the different, parameters, the methods that you can access, how to create a tool, for example, so you can read about it here, how to generate or how to simulate, learn about each and every operations in here. And you can also access the same help content from within a machining operation. So if you edit the machining operation and you go and select the help, it'll take you directly into that particular help topic as well. So these are context-sensitive helps, which automatically takes you directly to the specific topics. Now, for help with how to use the software, we have videos in here. So you can go into videos, and this takes you directly into VisualCAMc's YouTube channel, and you can basically access all of the videos in here. You can also reach us for support by selecting feedback, where you can send us your feedback and comments, and you can write to us for support and share your Onshape document with us by submitting the request right in here. And you can access the What's New document as we release updates to the product as well.
Joe, there was a question, maybe you can take this, is related to data. Where is that saved and whether they can
Well, yeah, so Onshape, this is the integrated cloud app. They're storing the data in the Onshape document, so it's just like the Onshape data. You're stored in the cloud, without getting into more details about it. But it's taking the same storage method as your Onshape data. It's not and I think what we can get into more details about that offline if you want to, but I would say that's a simple thing. And keep in mind, versioning, branching, all of that is honored here, so you can use those to your use the power of versioning as part of your machining strategy.
Yeah, there was a question also related to, is there a demo period for evaluation? Yes, there is. There's a 14-day trial of the product where you have the access to all the features and functions, including post-processing and simulation as well. So
yeah, all you got to do is go to the App Store, guys. Uday, why don't you pull up the App Store? It's all there right now. Every one of you could have been machining as we were in this this webinar. It's a single button to start, and like everything in the App Store, Uday's button shows that he's already a free user, a special free user, but he's clicked it, so it shows what you have. And like I think Joe mentioned earlier, there'll be a right now you can do it per month, but you'll be able to upgrade to an annual subscription in a few weeks, and that'll be a probably, I would imagine, like everything is probably the most attractive. That's what most of our users have migrated to, is annual subscriptions for just about everything. There's a question on units. I'm not sure. Yeah, you can. I don't want to answer it too much. I know that you can build it, and I do it by mistake all the time. You can build a part in inches and machine it in metric, right? As a integrated cloud app, you honor the units in the products.
Right, units are the document, yeah.
Yep. The cutting tools. Well, you can switch your library. So Owen was asking about metric and English. Yeah, you can switch libraries. I don't know, are the libraries unit specific? They are, aren't they, or not?
You'd have to have a library for tools for English units, which is inch, and you have one for millimeter units, so you can have two separate libraries. You can have all of them loaded in here, so depending on the units that you're working in, I can select from a metric unit library for programming parts that are in millimeter units, and I can select an inch unit library for programming parts with inches. So you can have multiple libraries loaded in here, and you can just toggle the library that you want to be active, and you can drag and drop the tools from it.
There's another interesting question about bridge options for our desktop customers. This is something we've been thinking about and definitely will be rolling out pretty quickly because a lot of our desktop users have expressed interest in running a cloud version. Some of you might be aware that we offer a bridge option for people to use multiple plugins on the desktop. With one license, you could use multiple plugins. Obviously, the licensing system is completely different on VisualCAMc C because we're going through the Onshape licensing, and so we won't be able to offer you a licensing that is as simple as the one on the desktop. But we will definitely have some sort of bridge option in terms of pricing. So we're able to run both the desktop as well as the cloud product simultaneously. So that's coming, so we'll let you know as soon as we have a pricing policy in place.
Okay, I think we've got to the end of, I mean, unless anybody has any more questions, we getting to the end of the time period, and I think we've answered most of the questions, so we'll give it another minute or so if anybody has something else. Oh, yeah, and they're two Owens. Wow, I can't see that. So let's see.
And two Joes, not to forget the two Joes.
Yeah, I mean, we don't have a lot of imagination and a lot of Johns in our. Like I said, this will be recorded, so if probably takes us about a day to get it posted from the time we record it. So within a day or two, there'll be an archive here. But honestly, this is a product. Get in and subscribe to it and start using it. You know, I think this is. How long have we been working on this? This is a product that's had a lot of resources put into it for a year and a half or so, at least, if not more. I mean, just as a work in progress. So
it's we had a year and a half of beta, but remember that the product itself has been in the actual algorithms have been tested out for 20 years. So the actual machining part has been around for a long time. We've done the beta just for the interface and the putting it on the server and working with how to send data back and forth to the server and the display and things of that sort. Just the interface part. So from the machining standpoint, it's all robust. 20 years of development experience has been built in. And this 1.5 years of beta is really fine-tuning it on the cloud, how to make it work on the cloud. So
it's been our most popular product as far as people signing up for beta. So there's clearly a lot of interest in the Onshape community for a pro-grade CAM tool. So.
Yeah, and folks, please get on board. We have a trial. Send us feedback because a lot of people are asking different functionality, and we're going to be driven by what you're asking, our customers are asking. So we have a lot of that. We'll start migrating pretty soon. So, and the nice thing about the cloud product is we don't have a yearly releases. You don't have to wait an entire year for the releases. We will be rolling these features as they become available. So.
All right. Well, thank you, everybody. I think this was, there is one good one, actually, cutting time. Do we give that? We do, right? The show how long it's going to take for a particular...
No, that's something that we're going to put in right away. This is somebody that came up with...
Yeah, definitely needed. So the idea of getting how long it's going to take to cut a particular toolpath or the whole thing,
So this will be part of the tooltip. We are actually working on it. As you hover the cursor over a operation, you see the information regarding that machine.
Yep.
You're going to see the cutting time also there. So you see the cut feed.
Someone got you on one thing. Right. Fun one. I should have stopped overhead. All right. I'm kidding. It's coming, guys. And I think Joe answered this before, but as they add, I think is a good ballpark to just go look at your existing price point for your desktop applications to give an indication of pricing for the cloud. Is that
That's
a good
true.
way to
Yeah.
go?
Yeah.
Yeah. So if you want to kind of get a feel for what 4 or 5 axis, simultaneous 5 axis costs, I would just go to their website. And I don't think it's completely nailed down yet, but it's a good ballpark, right?
Right. Yeah. And we'll be learning as well as people start using the product, our server costs and how much is this costing us. And so it depends on a lot of that as well. So.
Laser cutters. How does this work with the laser cutter?
We currently do support it using the post-processors. We don't have a separate laser cutting method, but we can use profiling toolpaths and a special post-processor to handle that. So
you need to create a 3D model out of it and then just do like the profile cut or something like that, right?
Yeah.
Yeah. Yeah. So it'll work.
Same thing with flame and same thing with water jets and all that. So
Nice. Okay, everybody. Thank you very much. I appreciate the time, and I look forward to this product being used a lot, and we'll help you out. And I can always be, reach me too if you guys have questions.
thank you all.
And Joe, Uday, thank you.
Thank you.
Take care.